number 39, we're asked to perform the indicated operations and simplify. This is from our rational expressions unit. In part A, we have an addition problem. Notice that with fractions, you cannot add them unless they have a common denominator. So the first thing that we need to do is find a least common denominator in order to move forward with this problem. The LCD for part A has to have factors of x plus 5 and x plus 4. Notice that the first term has the x plus 5 in it, but is missing the x plus 4. Therefore, we need to multiply the denominator by x plus 4 so that it has the complete denominator, but if we do that, we also need to multiply the numerator by x plus 4. Doing that gives us x squared plus 4x on top and our LCD on the bottom. Now we need to rewrite the second term with the least common denominator. Notice it has the x plus 4 already, but is missing the x plus 5. If we're going to multiply the denominator by x plus 5, we also need to multiply the numerator by x plus 5. This gives us 5x plus 25 in the numerator, and again, we have the LCD in the denominator. Our final answer will be to add these two fractions, noting that they keep the common denominator of x plus 4 and x plus 5, and in the numerator we'll just combine like terms. We'll work from highest degree to lowest, or standard form, and we'll write x squared plus 9x plus 25. You can leave the denominator as it is, or you could multiply it out, but that's just an extra step, so I suggest leaving it as it is. Let's go on to part B. Part B is a very similar problem, just subtraction, noting that we need to have a common denominator in order to subtract. This time, our LCD must contain the factors x minus 3 and 2x plus 1. Again, we'll rewrite each term of the fraction with the new least common denominator, x minus 3, 2x plus 1. The first term already has the 2x plus 1, so it needs the x minus 3. If we multiply the denominator, we must also multiply the numerator. The numerator, after we multiply, 4x times x gives us 4x squared. 4x times negative 3 gives us negative 12x. We're going to subtract from that the second term after we rewrite it, again with the denominator x minus 3 and 2x plus 1. The second term has the denominator x minus 3, but it's missing the 2x plus 1. We'll need to multiply that in the bottom and on top. Again, don't forget to distribute to both of those terms. 2x times 2x is 4x squared. 2x times 1 is just 2x. Our final answer here will have x minus 3, 2x plus 1 in the denominator, and in the numerator we will need to combine like terms. Remember, we are subtracting the second one, which means we are subtracting both of these terms. So the parentheses there might help you remember that. 4x squared minus 4x squared is actually 0, and negative 12x minus 2x is negative 14x, and that will be our final answer. Notice part C is a slightly different type of problem. Again, it uses the LCD, but this is a complex fraction. What we want to do with a complex fraction is we want to get rid of the two denominators. We're going to do that by multiplying through by an LCD made up of those two denominators. There needs to be a factor of 3 and a factor of x. When I say multiply through, what I mean is that we're going to multiply by 3x over 1 over 3x over 1. This fraction is just another name for 1, since we have the same thing in the numerator as we do in the denominator. This is what allows us to do this multiplication. To make things a little bit easier, instead of showing distribution here, I'm going to rewrite this 3x over 1 on both sides. That way I can show any cancellation that occurs, making my multiplication a little simpler. When I multiply 3x by the first term in the numerator, notice that the 3's cancel out, and x times x is x squared. Multiplying negative 4 times 3x just gives us negative 12x. We're finished in the numerator and now need to work on the denominator. 3x times 5 is 15x. And on the bottom right, notice that when we do the multiplication of 1 over x times 3x, the x's cancel out, and we just get 1 times 3 is 3. This is the answer to part C. If we were able to factor and cancel anything else, we could possibly simplify it further, but that does not occur in this problem.